Today on How It's Made. Glass bottles. Clearly fascinating. Hacksaws. We're off to a tool factory that's a cut above. And ice hockey goalie masks. Making them is a face-saving endeavour. But first... glass is made of natural ingredients that are abundant. Making it uses less energy than producing metal or plastic, and it can be endlessly recycled. Whether they're coloured or clear then, glass bottles and jars are always green. The recipe for glass combines several natural raw materials. The main ones are silica sand, soda ash and limestone. Silica sand usually makes up about 45% of the batch. The soda ash helps melt the silica evenly. It makes up about 15%. A limestone content of about 10% makes the finished glass more durable. These ingredients are combined with recycled glass called cullet. The factory's equipment feeds precise amounts of the materials into a furnace. After 24 hours at 1500 degrees Celsius, a gooey liquid that's the consistency of honey is produced. The molten glass pours out of the furnace. Shears cut the flow at precise intervals to produce cylindrical globs. Each glob is the exact amount required to make up one bottle or jar. They drop to a device called the scoop. The scoop moves them to troughs that feed them to jar-forming and bottle-forming machines. A glob of molten glass goes into a preliminary mould. In a matter of seconds, it comes out as a miniature version of the bottle, known as a parison. Each parison then moves into a blow mould, the cavity of which is the shape of the final bottle. The equipment blows compressed air into the parison, stretching the glass outward towards the wall of the mould cavity. This process creates the final bottle shape and hollows out the inside. These are amber-coloured beer bottles. The colour is produced by adding small amounts of iron, sulphur and carbon to the glass mix. A similar manufacturing process is used to produce other types of bottles and jars. In this run, the company is making 375 millilitre wine bottles out of clear glass. This run is producing bottles also out of clear glass. This mould though has a special feature, a recessed insignia on one of the walls, which produces a raised insignia on the front of the bottle. After the bottles leave the forming machine, they travel through flames. Otherwise, they would cool down too quickly and crack from thermal shock. A loader now gently pushes the bottles into what's called an annealing layer. The bottles cool at a controlled rate as they move through the layer. This gradually releases the stress from the glass. As the bottles exit, they're sprayed with lubricant. This enables them to move smoothly through the rest of the inspection and packaging line. The bottles now line up in single file to head into the automatic inspection station. As the machine spins each bottle, cameras and probes check for imperfections such as cracks or bubbles. The inspection equipment then examines the top to check dimensions and ensure the threads for the screw cap are moulded correctly. Before shipping, each bottle gets a final visual inspection. The proportion of cullet in glass can be as high as 90%. Cullet melts at a lower temperature, so for every 10% of cullet in the mix, the factory uses up to 2.5% less energy to produce its glass. Now that is a clear incentive to recycle. From big saws to jigsaws, handsaws to bandsaws, even backsaws to hacksaws, all these tools have their specific purpose. Hacksaws are chiefly for cutting metal or other tough materials. So what is it that gives them their cutting edge? Hacksaw blades are made from a wide range of steel alloys. Here, a thin band of steel feeds into a machine that cuts it into blanks of 30 centimeters long and 1.3 centimeters high. The blanks are loaded into a jig, 300 at a time, where they're compressed into a block for easier cutting. The block is then fed into a machine called a mill grinder. It cuts teeth into the upper side of the blanks. A water-based lubricant washes away the metal particles. This hacksaw model has a 24-point blade. There are 24 teeth every 2.5 centimeters. A brush is used to remove any metal residue. The quality control department inspects each blade for flaws. Then it's off to the next phase. A separator detaches each of the 300 blades, aligns them, then sends them through a setting machine. The machine bends the teeth to either side at a slight angle. This is called offsetting. It will enable the blade to clear away particles as it saws, preventing it from jamming. Now it's time to harden the teeth. The factory does this by heat treating the metal. A worm gear aligns the blades to enter a heating coil. In this process, the electromagnetic heating coil heats the teeth to temperatures as high as 1200 degrees Celsius, depending on the type of metal. This takes no more than 2 seconds. After the blades exit the heating coil, the surrounding air cools them down over the next several hours. This phase is called air quenching. The blades are now ready for printing. An offset printing press applies ink to raised lettering on a cylinder. That cylinder transfers the ink to strips mounted on another cylinder. These strips then print the company name, the blade length, and the number of teeth per inch on the side of the blades. Now, a machine inserts the blades in groups of 5 into slots, called fingers. The fingers rotate the blades and place them on a conveyor belt. The machine raises the blades and tapes them together at one end. This makes it easier to transport them to another part of the factory, where production continues. Next, the hacksaw's frame, the component that holds the blade, is made. The frame's components are placed in a jig that's positioned on a rotating carousel. A robotic welder fuses the components. A press punches 3 holes in the handle for attaching a foam or plastic grip. The 2 halves of the grip are fitted into a sonic welder that fuses them using high-frequency sound waves. The sound waves create friction at the seam, and this generates enough heat to melt the parts together. Now the frame is ready for the blade. An automatic device tightens a wing nut to put tension on the blade. Randomly selected blades receive a final quality control check. The testing machine cuts through a block of stainless steel. The machine performs this test 6 times per blade. Then the computer calculates the average number of strokes. If that average falls within the norms for this particular model, the batch gets the thumbs up. Keeping those thumbs, of course, well clear of the blades. Coming up on How It's Made. It's a 2-part special looking at how you can save face on the ice. Jolly hockey sticks. See you after the break.
התעשיות הכבדות מניעות את העולם המודרני. הן משתמשות בתהליכים מדהימים שלרוב איננו רואים. יש בהן טמפרטורות גבוהות יותר מלבה מותכת. פיצוצים גדולים מספיק כדי להזיז הרים. טכנולוגיות שהגיעו הישר מהמדע הבדיוני. ומקומות מהקטלניים ביותר על כדור הארץ. אני ג'וני סמית.